Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra class. We are continuing with linear equations today. And before you can really be a master of this, there's a lot of different little pieces that you have to really understand. And I already repeated this once yesterday. I'm going to repeat it a lot so it gets ingrained in your head. There are three forms of linear equations. Three forms. You have the slope-intercept form, which is y equals mx plus b. I promise we'll get there. You have the point slope form, which is y minus y1 equals m times x minus x1. I promise we'll get there. And then today, we're going to learn about standard form, which is ax plus by equals c. So today we will learn about standard form, which is the best way to graph linear equations when using x and y intercepts. These x and y intercepts are very important, and you really got to pay attention today to understand how to find intercepts and what they actually mean, okay? But let's walk before we run. The standard form of a linear equation equals ax plus by equals c, where a, b, and c are real numbers. Okay? Real numbers, again, that's any number. And a and b are both usually integers. So when you're writing an equation in standard form, if your a, which is the number in front of x, or your b, the number in front of y, if those guys are fractions, you have to make them integers. Does anyone remember how to get rid of a denominator in an equation? We went over this a lot, guys. Don't you have to multiply by the greatest common denominator? Right? The least common denominator? To both sides to get rid of those fractions. I'm telling you now, guys, fractions are going to be with you for the next 5 years of your life, for sure. So you have two choices. You can either accept it, learn it, and work with it easily. That would be the choice that I would make. Or you can choose to fight it, to get upset that you don't want to, and then you're just going to see that you're just going to suffer and suffer and suffer because fractions are not going anywhere. So you have to practice those fraction skills, please. Okay, so sometimes you will be asked to convert a linear equation into standard form. Simply manipulate the equation so as to put the x and y together on one side. You want to isolate the constant in this case. Remember that a constant is just a number by itself. Like the number 5 or negative 18 or 12. Okay? That's what you want all by itself when you write a linear equation in standard form. Okay? You want the x and the y together on one side, and you want the constant all by itself. Now, the usefulness of the standard form is when you want to graph using x and y intercepts. What are these intercepts, Mr. Morrow? Okay, let me explain. I want to show you a little visual here, so that way you could really, really make sense of this. Okay? All right. So I have here, says that the x-intercept, we'll do that in blue, is the x comma 0 point. What does that mean? Remember that in ordered pair you have the x value comma the y value. So what did I replace the y value in this case with? With a 0. So the x-intercept, please pay attention, is the x value on the x-axis when y equals 0. So for example, this right here is an example of an X-intercept. That point right there is 1, 2, 3, is 4, 0. It's the X value on the X-intercept when Y is 0. So if I want to find an X-intercept, simply replace the Y with 0 and solve for X. I'll repeat that. If I want to find the X-intercept, simply replace the Y with 0 and solve for X. When you write your point of the X-intercept, though, please remember, it's the X value, 0. Okay? That's the X-intercept. Does that make sense so far? Okay, awesome. Now in red, we'll do the Y-intercept. The Y-intercept is exactly the same, but it's reversed. The Y-intercept is exactly the same, but it's reversed. So in this case, it's the Y value when X is 0. If you notice here, I replace X with the value of 0. Very good. So the Y-intercept is the Y value on the Y-axis when X equals 0. So for example, this is a Y-intercept because it's a Y value on the Y-axis when X is 0. And what is this point? This is 0, 1, 2, 3, 4, 5, 6, 7. 0, 7. And that's how you write X and Y-intercepts. Now, what's the point of this, Mr. Morrow? Good for you. Yay! We graphed it. So what? Now, guys, the beauty of this, you can go ahead and connect the dots now, and you have a line. Now, some of you may say, wait a second. Why can't I just graph it normally? This is going to be a lot quicker. Okay? So that's how you find an X and Y intercept. Any questions so far? Yes, sir.
So once you find X and Y intercept, you can graph, it will like now be the line that.
Correct. The question was correct. The question was that once you graph the X and the Y intercept, you just connect the dots and make a line? Yes. That's exactly correct. Exactly correct. Any other questions? Okay, thank you very much. Now, let's go. Let's do it. Let's go back to the first skill, though. The first skill I talked about was writing an equation in standard form. So, what is an equation of the line y equals 3/4 x minus 5 in standard form? Well, I've got y equals 3/4 x minus 5. I want to get the x and the y together on one side, and I want the coefficients of x and y to be integers. So what do you think the first step would be? Yes, sir. Yes, sir. Okay, how do I get rid of that denominator of 4, my man? Very excellent, my brother. You're going to multiply everything by the LCD, which is 4 in this case. So 4 times y is 4y. 4 times 3 is 12 divided by 4, that's 3x. And 4 times negative 5 is negative 20. Excellent. Now I have my coefficients, my a and my b, as integers. They're no longer fractions. Now, how do I get this to be in standard form? That's absolutely right. Great job, kid. Subtract 3x to both sides. So now I have negative 3x plus 4y equals negative 20. Now you are in standard form. What's your a here? Negative 3. A is the number being multiplied to x. It's x's coefficient. What is b? 4. 4 is the number being multiplied to y. That's called b. That is y's coefficient. And what is c? Negative 20. C is the constant. It's a number by itself. Excellent, gentlemen. Excellent. Yes, sir.
What did you multiply the 4 to?
What did I multiply the 4 to? To everything, son. 4 times y is 4y. 4 times 3/4 is 3x. 4 times negative 5 is negative 20. Whenever I want to get rid of a denominator, I multiply the LCD to everything, my brothers. Everything. For example, what is an equation of the line y equals negative 3/7 x plus 5 in standard form? Okay, what's the first thing you think you should do, since I want, according to my directions, I want you to use integer coefficients. I need to get rid of that fraction. Excellent, son. How do I do that, my man? Multiply by the LCD. What's the LCD here in this case? 7. Very good. So you're going to distribute. 7 times y equals 7y. Very good. And that equals, what's 7 times negative 3/7 x? Negative 3x. Because yes, 7 times negative 3 is negative 21. But negative 21 divided by 7 is negative 3x. And then you multiply 7 to the 5. So you have plus 35. So far, so good. We got rid of the fractions. Now, how do I get the x and y together? Yes, sir. Go for it. I believe in you. Okay, what's your question, my man? Do you always have to identify the A, B, and C value? Not necessarily, but I'm a teacher, so I want to make sure that I give you the tools in case they ask you anything about it, right? I wouldn't be doing a good job if I just do it the easy way. Thank you, my brother. Yes, sir. Good man. Beautiful. Excellent. He said you're going to go ahead and isolate the constant here, 35, by undoing subtraction, and you're going to add 3x to both sides. And then that's going to be 10x, right? Okay, for whoever said yes, I got you. You're not paying attention. You cannot add 7y and 3x. They're not like terms. So this is 3x plus 7y. I got you there, man. Equals 35. That's standard form. X plus y is simply x plus y, my friends. You cannot add unlike terms. Okay? The A in this case, yes, sir. Very good, is 3. What's my B? Excellent. And what's my C? Excellent, gentlemen. Excellent. Okay, now, let's separate the A's from the B's here. Okay? Now this time, I got the following equation. What is an equation of the line y minus 2 equals negative 1/3 times x plus 6 in standard form? Alright? So I have y minus 2 equals negative 1/3 times x plus 6. Okay. I got to do a lot of calculations here. What's the first thing I have trained you to do? Distribute first, yeah. So I got y minus 2 equals, what's negative 1/3 times x? Negative 1/3 x. X in the numerator. What's negative 1/3 times positive 6? It'd be negative 2, guys. Guys, I heard people say it's negative 6/3. You're right. But negative 6/3 is negative 2. We have to reduce. Simplify. Yes, sir. The question was, is it possible to get rid of the negative 1/3 first? Yes. Let me finish this way, and then I'll do it that other way, okay? Now, from here, I've got a fraction here. I have a 3 in the denominator. How do I get rid of that? And what's the LCD I'm going to multiply to everything here? 3. So this is 3y minus 6, because I distribute, equals 3 times negative 1/3 x is negative 1x. Don't forget the x. And 3 times negative 2, negative 6. Okay, now what? I want to get the x's together, the x and the y together on one side. I want to get the numbers all together on one side. What do I do? Yes, sir. You can add 6 to both sides. Excellent. And you're going to have 3y equals negative x. Okay, now what? Don't I want the x and the y together on one side? So what do I do, guys? I add x. Don't let it stress you. I have trained you guys to ask yourselves questions. That is what my goal. And at this stage right here, when you got to here, instead of you guys just flipping out and going, oh my God, I've never seen that before, use your skills. Isn't standard form ax plus by equals c? So don't I have to get the x and the y together no matter what? So if you see that you have 3y equals negative x, what is stopping you from saying, oh yeah, I got to add x to both sides? One person told me what to do, but the rest of you seemed lost. How can I help you? How can I help you understand this? You guys understand? All right, let's do it. Now the fun part. Find the intercepts of each equation, then graph the line. Now, I want to show you guys that you could do the following. You could subtract 3x to both sides, solve for y. Go 4y equals negative 3x plus 24, divide by 4, and then you have y equals negative 3/4 x plus 6. And then you start making a table, and then you can graph it. That is one way to do it. But today, we're learning a skill that allows you to do a little shortcut. But this shortcut is only really valuable, okay? It is only really valuable if A and B are factors of C. If A and B are not factors of C, you can still use this procedure, but you're going to get fractional answers. And remember what we said about fractions and graphing. It's very difficult to graph fractions correctly, so always keep that in mind. If A and B are not factors of C, don't do it this way. Solve for y and do it the table method. So, first question. Are 3 and 4 factors of 24? Okay, now, what did I tell you that the X-intercept equal? What's the definition? The X-intercept. What is the definition? The X value on the X-axis when Y is 0, correct? So if I want to find the X-intercept, what do you think I'm going to make my Y? 0. So in essence, that's gone. So now I'm just left with 3x equals 24. What does x equal? So my X-intercept is 8, 0. The x value when y is 0, which would be right here. Does everyone see that in red, the X-intercept? Talk to me, guys. Now, the y-intercept. We said that in order to find the y-intercept, what do we need to make 0? X has to be 0. So to find the y-intercept here, make x 0. Plus 4y equals 24. That goes bye-bye. Divide by 4. Y equals 6. So the y-intercept is when x is 0, it's the y value. So 0, 6, 1, 2, 3, 4, 5, 6. And now I have my x-intercept, my y-intercept. Connect the dots nice and neatly, and you have your line. So to find the x-intercept, make y 0 and solve for x. To find the y-intercept, make x 0 and solve for y. Yes, sir. It's not a shortcut, this is just the procedure. The shortcut is even easier. But the shortcut can't come until you really understand it. I'll show you the shortcut on the last one, okay? Now, again, for B, I got x minus 2y equals negative 2. You can solve for y and make a table. But that's going to be a lot longer than what we're doing, right? First of all, what's the coefficient of x? What's the A? 1. Is 1 a factor of 2? Absolutely it is. 2 times 1 is negative 2. Yes. Is 2 a factor of negative 2 or a factor of negative 2? Yes. So they are factors, so we can use the procedure. So I want to find my x-intercept. When I want to find my x-intercept, what am I making 0? My y. So I have x minus 2 times 0 equals negative 2. That goes bye-bye, so x equals negative 2. So my x-intercept is negative 2 when y is 0, which would be right there. Negative 2 comma 0. Now in red this time, I'm going to go y-intercept. I find my y-intercept by making what 0? So I got 0 minus 2y equals negative 2. The 0 goes bye-bye. Divide by negative 2. Y equals 1. So my y-intercept is 0 comma 1. Right there. I have my x-intercept, I have my y-intercept, connect the dots, and you have a line. Does this make sense, guys? Okay, now, let me show you what I do in my head. And it's not a big deal. I'm not so special. It's just nice and easy. Okay? Nice and easy. What I do with my hand, remember, in the video, if I cover the screen, you guys know what I'm doing, but the people in the video don't. So I'm going to pretend that the star here is my hand, okay? When I want to find the x-intercept, what am I making 0? Why? So isn't that in essence basically saying bye-bye to the y? Right? So when I want to find the x-intercept, I cross out the y. So what's x going to equal here? 5x equals 60. Divide by 5. X equals 12. So my x-intercept is 12, comma 0, because my y value was 0. Does that make sense? Now in blue, my y-intercept. In this case, for y-intercept, what am I making 0? So I'm getting rid of that x value, aren't I? So that's gone. So now what do I have? I have the equation negative 6y equals 60. Divide by negative 6. Y equals negative 10. Thank you. How do I write the intercept, though? 0 comma negative 10. Beautiful, guys. Beautiful. Okay, so my y-intercept is 0, negative 10. That's right here. And my x-intercept is actually 12, 0. I'm only going to 10. So I'm going to go an extra 11, 12. And now I connect the two dots with a straight line to the best of my ability. And you just graph the line. Yes, sir, and yes, sir.
When one is a factor of, like, let's say one of them was a factor of 60 and the other wasn't.
I'm going to do it now when they're not factors. Yes, sir.
And when, alright, let's say you get the answer, and you still need to list down.
You always need to list for me the x and y-intercept, not only because it's good for you, because a lot of times we do know it in our head, but if we don't write it down, we're human. We forget. Math is all about organization. And this way also, let's say that on a test you wrote the right points, but you graphed them inaccurately. I'm going to give you half credit. But if you don't do anything, you don't show me anything, I'm going to mark it wrong. Okay? Thank you, gentlemen. All right. Let's see how we would do this one by crossing out again. Okay? Let's try to do this one really without a lot of work. I want to find my x-intercept. So when I find my x-intercept, what am I making 0? Y. So I cross out the y. What does x equal? 10. So what's my x-intercept? 10 comma 0 because I made the y 0. Excellent. How about the y-intercept here? What am I making 0 for the y-intercept? The x. Yes. So I cross out to cover up the x. What's y equal? 4. Very good. How do I write that? 0 comma 4. Beautiful. Beautiful. So 0, 4, 1, 2, 3, 4. My x-intercept is 10, 0. I have my x-intercept. I have my y-intercept. Connect the dots. And bada bing, bada boom, you're done. All right? Now, I'm going to show you one where they're not perfect. And I'm going to show you what you would do. May I? All right. Let me show you what happens. All right, let's say I got 4x plus 5y equals 12. Okay? And I tell you, graph this by using x and y intercepts. Well, same procedures. Let's get my little star again. Help us out here. Whoa. Oh, okay, there we go. All right, so I want to find my x-intercept. For my x-intercept, what am I making 0? The y. Oh, let me make it larger. Okay, so that's bye-bye. This one's easy because 4 is a factor of 12. So what's my x-intercept? 3, 0. Excellent. Now, for my y-intercept, same procedure. I'm still making x 0, y'all. It's just not going to be as pretty. What's my y-intercept this time? No, not 5 over 12. 12 over 5. Divide by 5. So y will equal 2 2/5. How would I write that as a y-intercept? 0, 2 2/5. So I can still find the x and y-intercept using this method. Now, is this a good method for graphing, though? No. That's the thing. So, if I tell you just straight up, find the x and y-intercept, it doesn't matter if a and b are factors. Who cares? I can find the x and y-intercepts. If I tell you to graph using the x and y-intercepts, I strongly suggest that you make sure that the a and b are factors. If they're not factors, you're going to have to graph it a different way, because then you have to estimate this 2 2/5. You guys with me? Excellent. Any other questions, gentlemen? Yes, sir. Sure. If my boy said, okay, let's say, Mr. Mo, you told us to graph this. This in particular would not be a very good one to graph, regardless. Because this one has a 12 here. So when I solve for y, I subtract 4x to both sides. 5y equals negative 4x plus 12 divided by 5. Y equals negative 4/5 x plus 12/5. And now, make a table. Negative 2, negative 1, 0, 1, positive 1, and 2. Why am I using multiples, my moral 5 instead of multiples of 5? See how I have a denominator in both of them? Let's keep them fractional. When x is negative 2, what's negative 2 times negative 4/5? 8/5, right? 8/5 plus 12/5 is 20/5, which equals 4. Excellent. When x is negative 1, what's negative 1 times negative 4/5? 4/5. 4/5 plus 12/5? 16/5, which equals 3 1/5. When x is 0, what's y? What is that called when x is 0? What's y? What is that point called there? The y-intercept. Excellent. When x is 1, I got negative 4/5 plus 12/5, which is 8/5, which is 1 3/5. And when x is 2, I got negative 8/5 plus 12/5, which is 4/5. So this would just be nasty to graph in general. Okay? But that's what you would do. You would make a table of values and you're going to estimate it from there. There's not a lot like these. I just don't want this to creep up on you and then you not be prepared. Okay? Thank you very much, guys. I hope you learned a lot. Have a great day. Recording. Okay, guys, we forgot about one example. Sorry. That was my bad. Okay, check it out. A media download store sells songs for $1 each and movies for $12 each. You have $60 to spend. Write and graph an equation that describes the items you can purchase. What are 3 combinations of numbers of songs and movies you can purchase? Well, first of all, you know me, I like to label things. So I'm going to say that songs are X and the movies are Y. Okay? And doesn't this tell me that $1 for every song X plus $12 for every movie Y. Doesn't that have to equal $60? Now, do you want to solve for Y here, or do you want to use the X and Y intercepts? You want to use the X and Y intercepts here big time. Okay, what's my X-intercept when Y is 0? Cover up that Y, 60, very good. 60 comma 0. What's that Y-intercept when X is 0, y'all? 5, 0 comma 5. So now, I got to go really quick because the bell's about to ring. Just bear with me. Okay, let's go by tens on the X-intercept. So 10, 20, 30, 40, 50, 60. And let's go by ones on the Y. 1, 2, 3, 4, 5. Check it out, guys. 0, 5, that's my Y-intercept. 60, 0, that's my X-intercept. Connect the dots and stop right there. Why do you think you don't go into the negatives? Thank you. You cannot have negative songs or negative movies. Now, how many numbers of combinations can you have? Well, guess what, guys? Anything on this line could be a combination. Anything on that line is a possible combination. Have a great day. God bless you. Bye-bye.